Well, we plan to have 3 speakers. And our first one is Ryan from GitHub, and then we have Mary and Ben coming after. Scan the QR code, comment on the LinkedIn post, and you can enter to win some prizes. The prizes are going to be books. I think the book is on the slide, but I haven't looked at the slides yet, so I don't really know. But the books are not with me. What will happen is that you will have to submit your address, and we will ship the books to you. But yes, so welcome to our Generative AI and LLMs meetup. A little bit about AI Camp. How many of you guys have been to an AI Camp event before? Please raise your hand. Ooh, okay. So we're getting a lot of newbies, but also a lot of return people. That's great. So I've been part of AI Camp for almost a year now. And I've seen it grow a lot. So we started out with around 200,000. Now we're at 250,000. We've kicked off more local events. So if you are not from Seattle, please come see me. I would love to talk about having events in your city. Primarily what we do is we have these kinds of live events where people come and they talk about what is the most interesting, cutting edge kind of technology, especially in AI and large language models right now. Sometimes we also have workshops. If you guys aren't signed up on the AICamp.ai site, you totally should. This is, again, the same slide as the last one. And this is basically just showing you where some of our chapters are located. So we are all around the US, Seattle, Los Angeles, San Francisco, Boston, Denver, a lot of these areas. So if you're from any of these areas and you want us to have an event in your place, let me know. If you want to get involved, we are looking for community managers and people who are working in the AI ML space who want to give talks, people who are working at startups who can sponsor talks and things like that. And if you want to get involved, just email info@aicamp.ai. This is a list or a what is this? An image, visual, whatever, of many of the people that we have worked with and that we continue to work with. So also there is Keras Community Day coming up in, what day is today? Today is the 21st. So in like 5 days. So if you guys have time, you guys should also check this out. So we're also going to do a quick community shout out. I'm going to limit this to 3 in case there are more than 3, but let's just get a show of hands first. How many people are hiring? Anybody hiring? Okay, 1 guy, 2 people. Okay, so if you want to advertise the positions that you're hiring, would you like to come up and advertise the positions you're hiring, like 30 seconds, just real quick? Okay, thank you. Okay, cool. So you guys heard them. If you guys are working with large language models or large language model operations, go check out these guys. Who's looking for jobs or new opportunities? Anybody? Okay, you can go first. I saw your hand first. The lady with the, yes, the lady with the hair. Would you like to stand up? Oh, congratulations. I believe the person next to you also raised his hand. Did you raise your hand? Oh, it's the person next to you? Well, oh, okay. I just saw a bunch of hands go up like right here, so. Okay, cool. So in case you guys didn't hear, the first person is a UX designer. She is a software developer. I think the guy in the purple shirt, yeah? Did you raise your hand? Okay.
Thank you. So I was fortunately in a team that was competing for like a competition hosted by NASA, and unfortunately, our team actually ended up with like the fourth place in like like competition, which helped to predict like the pushback time for the aviation. So now I'm basically looking for any opportunity to allow me to grow my skill in this industry.
Are you a software engineer?
It depends how you define like software engineer.
Do you write software?
I mean, I consider myself a software engineer.
Okay, there you have it, guys. He's a software engineer.
Okay.
All right. If there are like maybe like one or two people who want to give like a 30-second thing here, I think we have time for that. There are a couple other people who want to do an advertisement for themselves. Hey, that guy over there wants to do one.
Hello, I'm Colin Price, and I just finished a boot camp, and I'm looking for a position in full stack development. I have a background in business, and then I also used to do stand-up comedy. So,
very nice.
All right, he's quite a prize. Keep that in mind.
I was really hoping for a joke at the end of that one. Looking for projects, collaborations, co-founders, if you guys are working on any open source projects, or if you are starting a startup, does anyone want to raise their hand for that? I think that person in the blue.
Hi, everyone. My name is Cindy. So currently I'm working as an associate professor in one of Canadian universities to teach counseling and how to do treat people's depressions. I'm looking for co-founders or developers who knows more about AI and machine learning to help me to treat more people with depression and psychological problems. Thank you.
Awesome. Thank you. Does anyone else want to volunteer to stand up in front of everybody and give a short little talk? This guy right here.
Hi, my name is Igor. I'm a web developer, and I am looking for a possibility to shift into a machine learning role. I have some experience working with OpenCV and training some my home models based on that. But yeah, looking for some full-time job. Yeah.
Cool. Last thing. Okay. Someone wants to say. Yep.
Hey, I'm Karthik. I work for Symbol.ai. I'm here advertising my company.
Hey, how's it going, man?
Hey, how are you? Good to see you. And we are doing some subset of a lot of those things there. We basically have a large language model called Nebula that's out there. You can Google Nebula LLM. We are looking to talk to people who have an expertise in machine learning, especially if you've deployed a bunch of larger language models. Come talk to me at the end of things. And we are also looking to host events. So I'll talk to you, my friend, after the event.
Swag.
Thank you.
Is anybody here hosting any upcoming events? No. Oh, interesting. Okay. So before we get started, obviously we're going to shout out, thank you to our sponsors. Oh, yes.
Actually, we have this little thing called GitHub Universe coming up in November. So that check out githubuniverse.com. It's in San Francisco, but everything will be online. This year, we're focused on AI, security, and developer experience, if I'm not mistaken. So check out githubuniverse.com.
Awesome. Thank you. So yeah, shout out. Thank you to our sponsors, GitHub, of course. They're providing the space, the food, the drinks, DataStax, which actually, Ben, are you in DataStax? Yes. Okay. Isn't Mary also part of DataStax? Interesting. Okay. And O'Reilly for the books that will be shipped to you if you win. And I believe that is the end of my presentation. And it is time for you to come up, Ryan.
We're here. Do we have lavalier action going? 1, 2, 3, coming in. All right, cool. Yeah, let's see here. And let's try sharing our projector here. Hey, we got it up. All right. Cool. So everybody, my name is Ryan J. Salva. I am GitHub's VP of Product, where for the last few years, I have looked after our AI strategy, which means that my team builds Copilot. So let's do a thing, right? I dislike the whole raising hands thing. So rather than do raise hands, we're gonna do a jaunty pirate yar, right? So who here has used Copilot? All right, that's pretty good. That's pretty good. All right. Let's see here. Who here has built an app of any kind using a large language model in the last couple of years? Ooh, okay, less of you. Okay, all right. Well, we've built the one. It happens to be the world's largest scaled large language model, and here it's actually worth noting. Like, I want to do a little bit of like history here. Hopefully, this is visible to those in the back. Like, it is worth saying that Copilot is quite literally like the OG original gangster, straight out of Compton, large language model scaled application before all of them. For those of you that maybe, I don't know, weren't paying attention the whole time, no reason why you should have been, the original app launched in 2021. That is more than a year before ChatGPT, Stable Diffusion, Midjourney, any of those. And so what I was kind of thinking about today is I was thinking about how I wanted to guide this conversation, what I wanted to talk about. I'm guessing that a number of you are probably thinking about how you might be using AI in your own jobs, right? So, for example, who here, again, a jaunty yar, who here is going to be using AI or large language models in a startup, whether it's your startup or someone else's? Oh, yes. All right. Who here might be using large language models in like a more established large enterprise? All right. Well, so together in that Venn diagram, there's a lot of folks here who are going to be doing this. So for the next 30, 40 minutes or so, I thought I would share some of the lessons that we've learned along the last, nearly 3 years now, building GitHub Copilot, so that you can apply some of that learning and maybe even avoid some of the same mistakes in your own applications. So, by the way, I am not a big fan of slides, so everything's in VS Code today. It's just, yeah. So we'll start with a funny story, because funny stories are always good. How did we actually get started working with large language models before any of those other things existed, right? Well, our journey, my friends, begins with a light side incident, right? I'm sure many of you have had to deal with some kind of like all five alarm emergency, big availability incident before. That's where it begins. At the time, I happened to be running our enterprise platform and infrastructure team, right? So the folks that are responsible for making sure that GitHub stays online. And we were getting hammered. Like, it was starting to redline. We thought that the data center was going to go down. And we're like, okay, is this a bad actor? Is this a malicious state government? Is someone trying to do a denial of service attack on it? What the is happening, right? And after a while, we're like, okay, figure out that someone is doing clone after clone after clone of these repositories. Then do a little bit more research, and we're like, OMG, it is freaking OpenAI who's doing clone after clone after clone of our repositories, because what are they doing? They're harvesting data. I totally get it. They're public repositories. It is out there in the wild, but there are better ways to go grab that data. So it turns out that a couple of years ago, a few years back, we actually did this thing called the Arctic Code Vault, right? Essentially what we did is we took a copy of the world's open source data and we put it in a seed vault up in northern Finland inside the Arctic Circle. And we're like, you know what? You want a bunch of repos? We got a bunch of repos. They're on these like silver gelatin things up in the ice, right? And so that's what we did. We ended up connecting back with them through our friends at Microsoft and bringing them kind of a big data set of all of the public code that was on github.com. And that is what kind of like really incepted, as it were, GitHub Copilot. Working with OpenAI, we were able to create large language models that were trained on Java and Python, C# and Rust and Clojure and whatever, you name it, right? But we didn't know what we were going to do with it. And so what did we do? We started experimenting a little bit, and pretty early on, we got to essentially autocomplete, right? You know, we've all seen it in email before, or a Word document or something like that. You start typing and you say, thank you, and then it completes, you know, I look forward to our next correspondence or whatever, right? Same kind of thing, except doing it for code. So that's kind of like how we got there. Now, today, where is that getting us? So I talked about GitHub Copilot being the largest scaled large language model application out there. So today, we're at roughly 1.7 million developers, right? We'll zoom in a little bit, so that's maybe a bit easier to see. 1.7 million developers, 27,000 organizations. By the way, Copilot for Business, the thing that organizations would adopt, it only went into general availability in February. So what is that, 5-6 months? And there's a lot of things that surprise me about that. I mean, one, I've just never seen a product take off quite so quickly. But the thing that really has surprised me has been who is adopting these products, right? It's not, I mean, yes, it's startups. Yes, it's individual developers. But a lot of it, it's banks. It's insurance providers. It's governments. It is all of the paranoid, security conscious organizations that you would generally expect to be late adopters, right? Why is that? Well, I don't know. I'm sure they each have their reasons, but I think what it really comes down to is some of those numbers a little bit further down. 55% faster task completion, 46% of new code being written. These large language models, they are freaking magical. Like, that kind of a productivity improvement, just applied to development scenarios, is the kind of productivity gain that is unlike anything that I have seen in my career, and I think has probably really happened in the last many decades of just technology at large, right? And so these organizations, these large financial institutions and manufacturing institutions, they also happen to have some of the largest engineering teams on the planet, which means that 5% productivity gains actually multiplies out to a lot of saved kind of financial kind of cost of delivery. It means that you can actually deliver a lot more. And if that becomes 55% or more, well, hot damn, that is a lot of benefit for an organization. So to get there, I said I'd talk a little bit about like, what was our history? How did we create this? Any guesses how big the Copilot team was in that first year? Throw them out. 4. Or was it 27 back there is what I heard? 7, okay, all right, small ones here. Any others? 50, 17, that's, you win the prize, my friend, close. We were about 16. We were about 16 folks. So, you know, there's some PhDs in there. There's a couple of traditional software engineers in there. You know, folks like me, more on the product side of things. And like 16, it's not nothing, right? You can do a lot of damage with 16 folks, especially if some of them are high-powered PhDs. I was basically dragging the team down. But like, what I want to demonstrate is this, is that 16 engineers are able to build a product that is about 1.7 million customers, 27,000 organizations. And what that means is that these large language models really make it very easy for a small team to create a big scaled product. Working with the large language models, and for us, it has been OpenAI models, you know, we were able to get to a very, very good demo, a very good MVP, something we could release as a technical preview, about a month, maybe a little bit more. You can actually get really far really quickly using these. Now, where the fun part starts is once you've got that technical preview out there, once you get that MVP out there, how do you actually build that into a scaled application that can consistently deliver good results, can do it at low latency, can do it in a way that actually enables those larger organizations to adopt it confidently? And a lot of that work, by the way, is not the AI and the ML work. It's not the experimentation, although all that is important, but it's traditional software engineering. It is the sometimes, well, dare I say it, kind of boring work that is just like making sure the billing works, making sure that people can sign up, right? Traditional software engineer. So let's talk a little bit about, I'm going to talk about our progression going through some of the technologies and some of the user models. I'm going to share these in the context of the product that we built, GitHub Copilot. But what I want you to take away from this is that these are not technologies, these are not UX paradigms that are specific just to developer tools. These are things that will carry over to other applications as well. If you're working with large language models, some of the ones that I see in startups more often right now. I see a lot of startups for legal contracts and legal paperwork. I see a lot of them for marketing copy. I see a lot of them for, did I say customer service already? Customer service, legal, marketing, that kind of stuff. There's a new one for developer tools every 10 minutes. There's probably been 5 startups that were funded with Series A while I started talking. So let's do this. Now let's actually let's do some actual work in the IDE and not use it as my poor man's slide deck, right? All right, inline, right? This was the one you probably know the best. It's the one that you probably have seen inside of your favorite email client or your favorite word processor. We'll do it in the context of a developer tool, right? So I don't know, start with a comment. I'll say like, create a class to manage customers using the, I'm gonna make some of these windows go away, sorry. I got too much stuff that's, there we are. Using the Stripe API, right? And I'll start typing here. Okay, there you go. Those of you in the back, it may be a little hard to see. I know with all the sunshine in here, it's difficult, but there's a little bit of gray text there. It says com.stripe.stripe. Basically, it's taking a natural language comment that I put above. It is inferred intent, and now it is giving me a completion. So I'll just hit carriage return, and now I can just, y'all, I can do this all day. Tab, carriage return. Look, Ma, I'm coding, right? Right. Those were one-liners. Those were easy. Let's do public, class, customers. Okay, this is a bigger one. This is good. This is good, right? Holy moly, y'all. Like, look at that. That's what tab to accept. That's, okay, I basically just got 50 lines of code for one comment, right? That is why we are seeing 46% of new code being written by the AI. Now, it's doing this for code. You can imagine doing for legal contracts. You can imagine doing for customer support. You can imagine doing for marketing, any of these things. But I'm in the business of software tools, development tools. So this is what we're getting. So this is inline. And this is where we started. In fact, for our in-market product, here we are nearly 3 years later. We're still selling the same thing. And people are still excited about it. But we're doing more. We're experimenting. We're finding things. So I said there was other UX models to kind of borrow here. So the next one we started experimenting with is transformative, right? And these are my terms. There's no standard industry name for this. But like transformative is, if you've ever been in your favorite word processing application, you highlighted some text and you made it italicized or strike through or bold, you performed a transformative action, right? It's a small incremental change to an existing bit of code. So let's do this. I'm going to highlight some code here. I'll just do this first method. And I'm going to go over here to a panel here. I've got what we call brushes here. And I'm going to choose the equivalent of my bold or italicized. I'm going to say list the steps. And by the way, this is an experimental one, so it's a little bit slow. But you can see it basically decorated it with some additional comments, right? In this case, this is not a really big change that I'm making here. Again, it's a small incremental change, but it's a way of saying, hey, I want to transform a little bit of existing content with a new thing. Then we said, you know what? By the way, this was about the time that ChatGPT got out. We're like, you know, this conversational stuff is kind of cool, right? When it's in line, right? When you're just, you know, doing this initial gray italicized text that we had up here, right? As I was typing along, I got some gray italicized autocomplete. Well, that is great when what you really want to do is you just want to, you know where you're going. You just want to get your thoughts out onto the page faster, right? The large language model's job is just to predict what you would have written anyways, right? Letter by letter, character by character, token by token, right? But there are times when all of us, we want a collaborator, we want a co-creator, we want someone to actually build with us. And that's when conversational AI becomes really helpful. So let's do some conversational AI, right? We got some content here. We'll open up a chat window. And if I'm looking at this code, let's see what we can do here. All right, so this code, it was not complicated. This is basically boilerplate Java using the Stripe API, simple CRUD operation, nothing fancy. But I am noticing here that it's fairly brittle code. There is literally no error handling that's going on here, nothing like that. So I don't know, let's do something here. Let's say add try catch statements for error handling. All right, here's how we can add those try catch statements. It's going to give us a response out here. I'm zoomed way in, so I apologize if it's a little bit, right? So we added in a bunch of try catch statements for update and delete. Cool, awesome. So we'll do it for update and delete. We'll add in those try catch statements. Good to go. Wow, it is hard working at this zoom level, right? Okay, let's do one better, right? Let's say, like I said, I don't really know how to improve this code at this point. Okay, I'm not that bad of a developer, but let's imagine that I did know how to improve it, right? So let's say, let's see, how can I make this code more resilient? Okay, now I'm going to get some ideas, right? I can do specific exception handling. Okay, apparently the existing error handling wasn't specific enough. That's fine. I can do logging. Ooh, that's actually a good one. Retry mechanism, right? If it's an API call going over the wire, you may want to retry that API call if it fails. Have a fallback mechanism. So let's go ahead. Let's add retries to each method using a common parameter, actually using a common parameter or common number for all tries, or for all tries. Cool. And so now it's going to go ahead and add in retries for me using max retries here, right? Essentially, I am asking the AI what I want to do or what I should do, and then allowing it to write the code for me. Again, you could do this for legal jargon as well. How can I improve this contract? How can I add indemnification for this particular legal contract? And you can get back those kinds of suggestions. Last, right, in terms of UX mechanisms here, oops, I'm gonna go back over to this. So let's say that we get to something that's not just assistive. It's not just a window that's open off to the side helping me, but I want something that's immersive, that is a dedicated panel for it. So let me show one for that. All right. So here, I'm going to jump out of the IDE, and I'm going to go to my browser here. Let's see if I have here. Okay, here we are. So this is kind of cool. This, by the way, this is not this is internal experiment that we have right now. So y'all saw it here first, right? Not out there, not a generally available product. And what this is essentially Copilot for docs. What we're doing now is we have created a bunch of embeddings. We've done a bunch of indexing on, in this particular case, GitHub's internal documentation set, along with, and by GitHub, I mean like GitHub engineers, that we use to build GitHub.com, right? As well as our internal code base. And now I'm going to ask some questions about it, right? Let's say that I'm an engineer at GitHub. Primer happens to be our like our design system, our component library, right? And I've got some things that I can do here. I can say I'm a novice developer. I'm a badass. I can say that I don't know the material at all. I know it really well. I can say that I want a really detailed response. I've got some dials that I can turn here. So let's say like, I don't know, how do I create a table with options for sorting and filtering, right? So now what's going to happen is it's going to go back and it's going to index, or not index, it's going to query using kind of semantic search and embeddings all of our internal documentation and our internal code base. And it's going to give the GitHub engineering way of building out this user interface. In this case, a table with sorting and filtering. And the cool thing here is that because we've used embeddings, because we've used semantic search, not only do we get sort of instructions on how to do it, but we also get the equivalent of, I think of these as footnotes, right? These are links to our internal documentation that says, here is the source that most influenced this particular bit of this advice, right? And that can be really important when, as I'm sure you've all been exposed to this at some level or not, like sometimes the models can speak very confidently, complete bullshit. Like, it just does not work, right? And so because we're referring back to the source documentation, we're able to get to like, okay, is this actually truth? Is this actually something that reflects the way that GitHub would want to do it? And so I can link out here then to, here it is. It takes me actually to our design system documentation where I can validate and verify that that is the right thing. And when you're building technologies based upon large language models, that what often gets called traceability or kind of verifiability, right? Explainability, that becomes super, super important. Because again, you don't want the models to just recite out anything and lead someone towards a false conclusion. All right, so this is immersive. Immersive would be you are fully in a dedicated environment and fully dedicated user interface that's strictly for extracting information or creating new information.
Hey, Ryan, could you zoom in a little bit for our audience members in the back?
Sure, yeah.
Thanks.
This particular page is not that interesting because it's not the actual large language models, but let me get back over here to this. I'm going to close my chat window there. All right, so those were all UX patterns, right? Autocomplete and inline, transformative for like things like not copy paste, bold, italic, incremental changes, assistive for conversational UX, or immersive when you're in a dedicated environment. I want to talk about 4 other trends that we're seeing here. And I think you'll hear a little bit about embeddings and semantic search in the second talk. But retrieval augmented generation. So when Copilot is in the IDE and we are generating suggestions, I bet I can even get a suggestion to show up right here. See if I can. Yeah, that light gray italicized text, autonomous, right? How is it generating that suggestion? How is it building the prompt for it? Well, we're actually doing kind of like a poor man's version of retrieval augmented generation, or RAG, when we do that. Our prompt is actually taking context from a little bit before and a little bit after the cursor, right? Then, and this is the neat trick, right? What we do is we take that content a little bit before and a little bit after the cursor, and we perform a semi-well-known or at least well-understood algorithm that looks in adjacent tabs for similar content and packages that up to send to the model. Why do we do that? Well, the models work a lot like us as humans, right? If you were to ask me a question, I'm going to be able to provide a better response if I have domain expertise, if I have context into that particular question, right? Well, the way that we deliver context to models is largely through the prompts. And so I'm assembling context from as many files as possible in order to give the model better context. In a real world application, you can imagine this. Let's say I have one tab open that is my class with the business logic in it. I have another tab open that is, I don't know, unit tests that kind of run up against that class. Well, I'm going to get better responses if I pull my prompt from both the unit tests and the business logic. So retrieval augmented generation is basically grabbing data from multiple data sources, not just using, let's say you're using ChatGPT. It's not just a little prompt that you type in yourself in the chat window. It's, hey, go get data from a bunch of other places that's relevant to that initial query, right? When we do RAG in the IDE, think about each tab, each file as its own data source. That's cool and all, it's great, it's gotten us this far, but it gets better when you can then say, hey, don't just grab stuff that's local to the IDE. Also, go grab relevant content that is on github.com, that's in relevant repositories, where you're following kind of the dependency tree for that particular application, grabbing all of those imports that I had referred to back up here, and go actually pull content from that. So retrieval augmented generation, at its most simple, is just using a simple kind of like lexical search, right? It's just exact match, essentially. This is where the next piece of it becomes interesting, right? Semantic search and embeddings, right? So let's do another jaunty yar here, right? So who here feels like they completely and fully understand semantic search and embeddings? All right, I like it. Two jaunty yars I got. All right, so let's actually explore semantic search and embeddings for just a moment, right? So what's an embedding, right? Let's imagine we're going to create an embedding for an elephant, right? Literally the word, the concept of an elephant, right? So you could technically create an embedding as a human, right? Let's say that I want to create an embedding across 3 dimensions. Color, native region, and ability to remember things, right? So I've got 3 dimensions now, right? I'm an elephant, or I'm thinking of an elephant. They're usually gray. They're kind of primarily from like Asia, Africa, and they have an excellent memory for things, right? So let's do this. I'm going to do file. This is actually kind of helpful if we can illustrate this, right? So I'm going to use Copilot again. I'm going to say create notebook, create a scatter plot across 3 dimensions using sample data. So, by the way, fun thing about Copilot as well is you can use it to just automatically create Jupyter notebooks for you when you're in the middle of a demo and need to illustrate how this might work. So we're just going to go ahead and we're going to run all. Hopefully I've got all the right things installed. Create the scatter plot. Okay, cool. It created a scatter plot for us. So we now have 3 dimensions. What did I say? Color, region, and memory. And imagine that all of these are not just for elephants, but they're all sorts of different animals, right? Now, when you're creating an embedding, what you're essentially doing is you're saying, you know, in this 3-dimensional array, all the things in this circle here are approximately the same. I don't know, mice are also gray. You know, there's some in Africa and Asia. And let's just for a moment pretend that they have good memory too. I don't know, Mickey Mouse has got good memory. And so like those 2 dots are kind of close to each other on the scatter plot. Well, when you're creating an embedding, what you're really doing is you're saying, rather than 3 dimensions, let's let the models find relationships between words, between concepts, between things that are out there in the training set. And like we're not as a human curating what those dimensions are. I used color, memory, and region, but we're letting the AI determine where there are logical relationships. And the thing here is that when the AI does that, it's able to find so many different relationships with each other. In fact, today's OpenAI models create just north of 1,500 dimensions for any particular token or concept, right? So that's a lot of ways that things are related to each other. Now try drawing a circle. Well, I don't know. I can't think in 1,500 plus dimensions, but the AI can. And so when you're doing that, when you're creating an embedding, what you're essentially doing is you're saying, hey, across 1,500 dimensions, we found relationships that tie these things together. And so now when I'm performing a query for, I don't know, elephants, the AI can quickly find all of the different animals that are somewhat related or somewhat often found together with similar dimensions. Does that make more sense to folks? A little bit? Okay. So what semantic search allows us to do is even if we don't know what we necessarily want to, like the exact thing that we want, we're able to generally describe it. And then the AI can tell us, here's where to find all of those things, even though I don't know what to label them. I don't know what to call them. And that's how retrieval augmented generation works. It's using embeddings to find all the related content, to then deliver all that juicy content in the prompt so that we get better responses out of the models, right? All right. The other way that we get good responses out of the models is fine tuning. If embeddings and semantic search are in retrieval augmented generation are hitting the prompt side of the equation, fine tuning is hitting the model side of the equation. I won't give the same long-winded kind of explanation for it, but a good way of thinking about it is it's taking all of the parameters that are in the kind of like the default settings for a model. It's tweaking them or biasing them towards a slightly different training set, and then essentially teaching the model how to, a good way to think about it is it's teaching the model how to speak with a different accent, right? If the model like inherently tends to output code or language that speaks with a somewhat jaunty French accent, use the training to speak with a more severe German accent. It's just changing kind of the overall flavor of the model. And last is agents. I will skip over agents today because I got a 5-minute warning back there in a minute, but if folks want to talk about it afterwards, we can. I'm going to end with this though, right? I promised at the beginning that I would share a little bit about what we got right, what we got wrong, so that you could avoid some of the same mistakes. So along the way, one of the biggest things that I'm proud of, that I'm glad we did, is we led with research. And here, I don't just mean experiments through telemetry or just offline testing and that kind of research. It's not just software research. It's the human research. Because the only way that you will really know that these models, these kind of technologies are delivering real human impact is if you put it in the hands of real people and observe and measure. And so both our confidence in the product, the quality of our product, and our ability to take that product to market were greatly improved because we could relate it back to actual controlled studies. If anyone wants to see some of that, just go to the GitHub website and do the search for like Copilot research. You will find dozens of controlled studies that we have done in partnership with our user research team or even our engineers kind of working on their own. Next, optimizing for speed of experimentation, right? If you are not able to conduct experiments and conduct them quickly, you are automatically at a disadvantage to anyone else who's pursuing a product in the same space, right? Being able to experiment and iterate quickly, like that's oxygen, right? Third, if you're working with large language models, your biggest barrier to actually getting beyond individual user adoption, if you want to actually sell to any other business, any organization, is going to be like you're going to be blocked by security, privacy, and legal. You've got to anticipate how you're handling the data, what data you're retaining, the transparency of all of your kind of like statements about how you use that data. That kind of information is what is going to enable you and allow you to sell to larger organizations. And that leads to that last one. Be transparent with the ways you're using the data. Everyone is scared to death that you are using their data for your own profit and not giving anything back to them, right? And besides just being an ethical concern, it is also a real business concern for you if you're trying to use large language models as a core part of your product offering. Now, the more entertaining lessons are always from what we got wrong. This is obviously a completely incomplete list, very abbreviated, but we optimized for inline code completions first. And we got freaking lucky. We found product market fit, lots of people adopted it. We were lucky GitHub had a good brand. But y'all, that is a low latency use case, and it requires a hell of a lot of GPUs because you're essentially doing inference at every keystroke. That is expensive and that is hard to deliver. If you are building any kind of application with large language models, I encourage all of you to go for something that is an asynchronous or kind of a use case that tolerates high latency and that users only go to occasionally. That is going to give you a much easier scenario to go to market with first. And then second, build the team, no faster. I talked at the beginning about us starting with a 16-person team. Yeah, that got us to a great MVP really quickly. You know, if we had been outside of a GitHub, Microsoft context, we would have gotten funding like that. And also, we felt the pain for the last 3 years because we did not scale up the team fast enough to anticipate all the other things about security, privacy, scale. And so if you are a founder, if you are someone who is even operating in an enterprise environment where you're expected to grow that business quickly, it's great to start small, but do not make the mistake of staying small forever because you will need the people in order to scale out. All right, that is it. My time is up. I think we have a couple minutes for questions, but thank you. Two? Yeah.
Let's try to take 2 questions.
Dave's coming over there. There.
When you iterate on the model, how do you evaluate those models and pick the better one?
Yeah, most of our iteration happens. I mean, there's stuff that we do on the infrastructure side of things in order to improve for latency, but I'm going to assume that you're talking primarily about how do we improve response quality coming out of the models. For the most part, what we do is we take a small percentage of traffic, right? We're lucky enough that we have, 1.7 million developers, so we can do it on like little slivers of 1% and 2% of traffic. We change one variable in that traffic, and then we observe a number of quality metrics. Our primary quality metric, certainly not the only one, but our primary one is the suggestion acceptance rate. So we look at, for a treatment group, did the suggestion acceptance rate increase? We'll also look at things like percentage of characters retained, percentage of characters retained, you know, whether or not the code like actually got a thumbs up or a thumbs down in the case of chat. So indicators like that. And if our quality indicators are better for the treatment group, then we roll it out to an increasingly larger and larger and larger percentage of the traffic until we go to 100% and we conduct the next experiment from there. Again, because we have 1.7 million users, we can actually conduct multiple experiments simultaneously, just using small slivers of the traffic, but we always keep them separated out. Interestingly, one of the things that we do in that is we never inspect the actual content of the suggestions. So we don't know the content of the prompt. We don't know the content of the suggestions that's returned. All that we know is we had a different methodology applied to our treatment group, and we look to see if it's better or worse. Dave? Oh, back there.
Yeah. Hey, you had mentioned
I'm going to repeat what I think I heard, make sure I got it right. When using semantic search, how do we ensure explainability? Yeah, we don't. Explainability in that case doesn't matter to us. What really matters to us is that users show us through their behaviors that they are getting accurate, good results. Frankly, with large language models, explainability is all that we can really do is say, hey, we have a direct mapping of this source content back to this embedding, and that embedding delivered this particular response, right? And so we know that there is a high level of influence between the source content and the model response that was delivered. And so that's a degree of explainability. We're drawing a straight line between those two things. But can we guarantee that that suggestion is an accurate suggestion, is a truthful suggestion? No. That's why we have the straight line between the model response and the source content, so that the user can verify that it's actually accurate. Does that make sense? Love it, love it. All right, I think that's all we have time for. Y'all, truly a pleasure. Thank you for letting me share what the teams are building. Really appreciate it.